have to discuss about the EIGRP. We have to understand what is the EIGRP, how EIGRP is going to work, and what is the key fundamental of the EIGRP. Because EIGRP is the first topic. We are not going to discuss the RIP. RIP, we just definitely have to understand. RIP having a limitations. If I talk about the RIP having a limitations, RIP can support till how many hops if I going to configure. Also, it is not going to be used, but any idea what were the RIP limitations, you guys?
15.
Yes, 15. So RIP having a limitations, it only going to support maximum 15 hope counts. If you have the 16 hope, it is going to be unreachable. So you can think in India to USA, if I want to send the packet, or might be have the LAN, very large LAN network, and I want to configure the RIP is not going to be supportable for me. So to avoid these solutions, means to avoid these problems, we use the different routing protocols, and that routing protocols further known as the dynamic routing protocols, and we have the EIGRP, we have the OSPF, and we have the BGP. So first protocol we have to think about, that is the EIGRP. This EIGRP is known as the enhanced gateway routing protocol, right? If you go and find the EIGRP, so you just search it, what is EIGRP? So you're going to find it is the enhanced interior gateway routing protocol. So if I just open one of the book as well, hold on. So if you go here, let me open the EIGRP book. Let me, so you guys are going to get some good idea. Hold on. Okay. So we are going to start, that is the official module, because we have to talk about. So this is the EIGRP fundamentals we have to discuss. Why EIGRP? So in this EIGRP, we have some quizzes and everything. I believe, just hold on. Let me, hold on guys. I believe, let me open this one. It's going to be more useful, I believe. Yeah, okay. Definitely I'll refer this book as well, but let me put this one. So we have to understand the EIGRP. So in EIGRP, you can see here, EIGRP basically we have some limitation of the RIP. RIP is basically, it is going to be your, it's not going to support unequal load balancing. It's having just 15 hope, right? And it was just limitations. But when I talk about the EIGRP, EIGRP have some great features. They are going to be scale your network. They are very versatile. And imagine if we have the 10 networks, right? And they want to build the big complex topology. They have the thousands of route, millions of route. Even that EIGRP is going to carry. And they can do the equal load balancing. They can do the unequal load balancing. But if I talk about the RIP, static, they are very unscalable. Even RIP is not going to support unequal load balancing. That's why we use the EIGRP, and that was the earlier, it was a Cisco proprietary protocol, but now it's open standard. Even for the different vendor, it is going to use the your EIGRP protocols. So think about in this way. Let's suppose I want to deploy the EIGRP. Shall I consider for the global deployment? If all my device is Cisco, that is fine. But if you want to use this EIGRP for the any kind of the deployment for the non-Cisco devices, still many devices are not supporting. Even you can think about the Palo Alto firewall, it's not supporting. FortiGate firewall, it's not supporting. Any kind of the other firewalls, different than Cisco, suppose it's not supporting the EIGRP because their hardware is not designed in such way who can support the EIGRP. They can support the dynamic routing protocol like OSPF and BGP, but EIGRP is not going to be supported. But because we are going on the Cisco syllabus, so EIGRP also going to be found in the everywhere of networks in the LAN infrastructure. So you should know in very good what is the EIGRP, how it is going to use in EIGRP. Okay. So first of all, EIGRP is going to be a Cisco proprietary protocol, and this is known as the, let me put it here, this is going to be known as the distance vector routing protocols. Also, it leverages the concept of the linked state. What is that? It's basically known as the hybrid protocol. Why hybrid? Basically, why it is going to be hybrid? Because they have the property of the distance vector plus it is going to be use the property of the link state protocol. OSPF is going to be purely link state. What is the meaning of the link state? I'll explain. But what is the meaning of distance vector? Anyone have any idea what is the meaning of distance vector?
It counts the hops. How far is your
Uh,
destination?
if I want to just understand the layman language, then how I can understand what is distance vector? Any
It,
idea?
it counts the number of devices, how far your destination is, like RIP.
What is vector? What is vectors? Anyone know?
Vector is like mm,
Sign?
point
Yes.
destination or
Yes. Yes.
two,
Yes.
two points in
So
specific direction.
let me show you. Vector is basically sign. This is the vector. Okay. So you might be. Let me show you. Delhi Dhalakua Road sign map. See, let's take this example. See, in this map you can see. Okay, so you see here, if I go on this particular diagram, it is giving the vectors. When you're traveling the road, right, you're going there. You reach this place, is saying that if you want to go Anand Vihar, you go in this way. So this is the sign and vector to go on the Anand Vihar. Then you reaching little bit move forward, then you want to go RK Puram, then go this way. This is another vector. You want to go Santiniketan, go directly. You go into Mayapur, you go directly. You want to go AIMS, go directly. So at these positions, when you reach from somewhere, right? Let's suppose this is your home. R1 is your home. Then you reach to the R2. Then you checking the vectors. How I can reach to my Anand Niketans, how I can reach to my RK Puram, and how I can reach to my Santi Niketans, and how I can reach to the my Mayapuri. So when you travel and then at certain node you have to check the sign. Then you move further and then you check the sign. That's the vector, distance vector. Means after every hop, they will just verify what is the direction to go to next hop router. It is clear? You understand distance vector concept?
Yes.
Yes.
Sabir, you?
Yes. Yes.
Rajkumar? Let me just go here and read this articles also. So see, distance vector routing is type of dynamic routing protocol where each router maintain the table showing a distance metric hop count as a vector for the next hop. Each router in the network. So basically distance vector router regularly send their complete routing table, their distance vector to immediately router. Means whatever the routing table they have, they send to their neighbors, and further based on that information that any person want to go in the next hop, they will just follow that vector and go that particular location. That's the vector. The second, they maintain the link state concept also. What is the link state concept? Why the hybrid? Because in OSPF, there doesn't have any kind of the vector concept. Means if you are running the OSPF, if you're running the OSPF, you are the this positions. It's going to act as a GPS. It's going to act as a GPS. At the same time, they have all path informations and their metric, how to reach from one place to another place. They complete maintain the routing table. But in the EIGRP, they also leverage the link state protocol. They maintain the topology table, right? They maintain the neighbor table, they maintain the routing table. But the problem is that link state protocol in OSPF, they have the full picture of the links. So at sitting in one positions, they will decide which path is going to better for me. In EIGRP also it is going to be same case. But some the line they leverage the distance vector protocol. So whatever the path they going to select as the best path, they use some concept like dual algorithm, and they're going to calculate the best loop free path, the fastest path, and they are going to use some additional concept as RD, reported distance, feasible distance, feasible successor, which we'll discuss later, advertised distance. So they are going to calculate the path based on the different parameters, but the end goal, it is going to leverage the concept even the link state, where it is going to be maintain the full routing table, but decision is going to taken every router how to reach to destinations. So every router is going to maintain their all topology table, and routing table database is going to say to the neighbor router. Neighbor router again going to send to the neighbor router by leveraging that. But when the packet is going to come, let's suppose you know how to reach this particular destination because your neighbor is going to send me. But when the packet again reaches to me, again I will verify my routing table. Again I will send to the next stop. He will again verify, again send to the next stop. Generally routing work in this way. But in OSPF, it is going to maintain full link state, entire topology, entire in their database. But in this case, they maintain the topology, they maintain the neighbor tables, they maintain the routing tables, but even they check the vectors for the every hop, right? So EIGRP is going to act as your distance vector protocol. That is one thing. Second thing, whenever you run the EIGRP, okay, EIGRP is going to be use the dual algorithm. What is a dual algorithm? This is going to be it is going to be use the algorithm that is known as the that is going to be use the dual algorithm. This is known as the diffuse. Give me 1 second. I just, yeah. So diffusing update algorithm, right? So if you are going to use the dual algorithm, what they are going to do that? They are going to select the successors, feasible successors, like feasible distance, your reported distance, advertised distance. And this dual algorithm, it is going to help to make sure whatever the topology you are going to build, that is going to be complete loop free topology, and there is no any kind of the loop in the network. And also at the same time, very important in the dual algorithm, they not only select the best path, it's very fast because they select one of the best path, that is a loop free path. But at the same time, this dual is going to use to select one of the backup path. Also, this is going to be loop free. So this dual is going to be used, and this dual is going to do your all job for the calculating the best path and non-best path. I hope this much is clear to everyone. So you are going to find this successor. I'll discuss that. But I hope we understand dual algorithm concept at least. So if I just let me find if I have the let me where is the document? I was just searching. If I can show you in the dual algorithm, this book is not showing this dual algorithm. I wanted to show you all. Even this book not having a dual algorithm concept. So hold on, I just want to show you about the dual algorithm as well. Okay, they just mentioned one line. EIGRP use the diffusing update algorithm dual to identify network path and provide the fast convergence in the pre-calculated loop path and the backup path. Most distance vector routing protocols use the hop count as the metric of the routing decision. Using the hop count path selection does not take the account link speed and total delay. EIGRP add the logic route selection algorithm that uses the factor consider hop counts. So hop count is going to be also there, and along with that, if I go and talk about the diffuse algorithm, you can see this EIGRP algorithm convergence mechanism that select the maintain loop free route by calculating and using the two type of the path, that is a successor, that is a main path, means your fastest path to reach your destination, and then they have the another path that is the backup path, and it is going to be loop free path again. So why it is fastest? In case of my primary path is going to be down for any reason, immediately it is going to shift the traffic on the backup path because they already have the backup path. Other route need to be recalculate the backup path. If I am running the OSPF as well, it is not going to put in routing table or might be the fib table the backup path immediate available in case of my primary is going to be down. No, it is not going to be happen. But in EIGRP it is going to happen. That's why it's going to be very fast convergence. And they use the parameter successors, feasible successors, feasible conditions, feasible successors like that is also it is going to dual active state and advertised distance, reported distance. So what is that we have to understand. But very first thing before I can go and explain the feasible conditions, your successor, feasible successors, we have to understand if I want to enable the my EIGRP, then how the different table is going to build, how the neighbor table is going to build, how my topology table is going to build, how routing table is going to build. That I will definitely show you. At the same time, I have to understand when I just build the OSPF neighborship, sorry, EIGRP neighborship, how my hello packet is going to be exchanged. What is the duration of the hello packet? How my any questions anyone have?
नहीं आपका भी लोडिंग नहीं
Santosh,
मैं कर रहा हूँ बस एक
please Santosh, mute yourself, man. Okay, so if I want to go on the EIGRP, then what is my hello time? Let's suppose you just build the EIGRP neighborship. So by default, they are going to exchange some hello and dead intervals, hello timers. So hello time by default is going to be 5 seconds. It's going to be hello time by default 5 seconds, and 3 time of this is going to be your dead interval. This is going to be your dead interval, means this packet is going to send the hello. Within 15 seconds, there is no reply is going to back. It will declare this neighbor is going to be dead. This is going in case of my link is Ethernet. In case my link is going to be Ethernet. In case of my any frame relay, that is not going to be used. Or if in case of NBMA network, that's again part of the non-broadcast multi-access. In that case, it is going to use a timer. It's 60 seconds and 180 seconds. So 3 time of the your hello timers. So generally we not use this one. You want to like increase or decrease the timer. It is absolutely possible. You can do that. But this is how it is going to be happen. Means I have to go and apply the neighbor conditions. Means I want to build the neighborship. Neighborship only going to be stable and up and working if they keep replying the hello and like hello messages. It is going to be exchanged between the routers, right? That is one thing. Now, whenever you go and configure the EIGRP, EIGRP use one of the key feature that is known as the autonomous systems. Means if you want to define the EIGRP without autonomous system, you cannot configure the EIGRP, right? So what is the autonomous system? Autonomous system is basically AS number. AS number it is going to use. Even BGP is going to be used the AS number. And EIGRP is going to be used the AS number. But BGP AS number is little bit different. EIGRP is going to be little bit different. EIGRP AS number is going to be local to the your internal network. Means whatever the AS number you are going to use for the EIGRP, that is going to be same for the all routers. It is going to be same. If you are going to different AS number, then you cannot build the EIGRP. Whenever you're going to build the AS number that is going to be different, that is not going to build your EIGRP. Why? Let me tell you. Whenever, let's suppose this is my one router and this is the another router. By default, when you configure the EIGRP, this is going to configure the EIGRP. This also going to configure the EIGRP. They will going to join one of the multicast address. This multicast address is going to be 0.0.10. Okay. So they keep listening. Means if someone is going to send any message, they will just listen because they are going to part of the same multicast group. Because we are in the same group, Zoom group. So you guys are going to say anything, I'm going to listen. If I'm going to say anything, you guys are going to listen because we are the same community, same group. Similarly, if I'm going to use the EIGRP, if I'm going to configure the any EIGRP, enable the EIGRP on this interface, or this network, we will by default the multicast address, that is a 224.0.0.10. This is the predefined multicast address for the EIGRP. Clear? And the router we're going to send the hello message, hello packet. This hello packet is going to send, and this hello packet is going to contain multiple informations. What is that? They contain very important information, that is the AS number. This is the one information. Second information, they contain the key values, right? Key values. They're going to include your subnet details, right? And then also going to include your authentications. Most important, AS number, right? And then key value, and then authentications. These three parameters going to be sent. So if your AS number is not going to match both sides, you cannot build the EIGRP neighbor safe. So if you go here and try to search even what inside of EIGRP, hello packets. See here. So very first important, they going to keep the AS number, subnet mask, hello, I miss that hello and hold time timer, because we have to also include that, because we are discussing, we discussed earlier. So hello and hold time also going to be there, and that key value, and they miss the authentications. Authentication is also going to be there if there is authentication enables. So anyhow, these parameters must be matched. If it is not going to match, you cannot build the EIGRP neighbor safe. So AS number is going to be local to the company, and that must be going to be same on both of the side. And whatever the key values, what is the key values? The key value is going to be, if you just going to here and type what is the key value, it's just going to matrix calculation. It just composite matrix calculation is the key values. So it is going to use K1, K2, K3, K4, K5. It is going to be K6 also in case of the named EIGRP. Not only the K5, they use the K6 as well. So it is used to calculate your bandwidth based on the bandwidth, delay, and load. They are going to use these all parameters: bandwidth, load, delay, reliability, and MTU. Based on that, they are going to calculate your metric. Means what is the metric to reach from one place to another place? Means you can think in this way. If I want to reach from one location to two locations, so how I can calculate? So I calculate this path is going to be my 10 kilometers. So this is my distance. This is going to be my 15 kilometer. So the kilometer is going to be parameter to calculate the distance between A to B node. Similarly, if one route is going to reach from one to another destinations, this key value is going to be act as your metric. Clear? Make sense, guys? It is clear, right?
Yes, yes.
So
Yes.
we understand hello is going to contain key parameter, that is the AS number, and you know what is AS number. AS number range is going to be, let me show you, EIGRP AS number range. If you're going to there, it is going to be start from this range 1 to 65535. Within this, any range is going to be assigned, but this is for the public one, this is for the private one. So whenever you configure the EIGRP, you just use this range. Basically, generally we go and configure the private AS number only. If you are going to use the public one, it is not going to be routable on the internet. Means it is routable on the internet, but definitely you don't have to do, because EIGRP 99% case you are going to run in the LAN. So you can use any AS number between this range except 01. But recommended you just go and use this one. But in lab you can use anything. Even for the LAN, unless you are going to use the VPLS circuit for the WAN internet, then you have to use the public one. Rest you are going to use the LAN, this private one. That AS number, right? So this is going to be range. You can use the range from 1 to 6535. This is going to be range. Now this is going to use the your hello plus dead interval timing. They are going to use your subnet mask. Then they are going to use most key values. Key value is going to use for composite metric. and they use authentication. What is authentication? Let's suppose you want to build the EIGRP neighbor safe. Here you set the key, right? 1, 2, 3, 4, 5, 6 as your authentication. This neighbor, if have the same key, like if they have the same key 1, 2, 3, 4, 5, 6, then only they will allow the neighbor safe. If one side authentication is configured, another side also must have the same authentication. If it is not there, you cannot do the configurations. Clear? So this is how it is going to happen for the authentication configuration. So this is the hello information. Similarly, if I want to build the EIGRP, we have the multiple packets. The first one is the known as the hello packet. Okay, and you know what is inside of the hello packet. Why hello packet? Because this is the initial, whenever you enable the EIGRP, it will say hello on multicast address 244.0.0.10. If in front of me, whatever the router I have, if it is going to find, yes, it is relevant to me and it's my community person and I also EIGRP enabled person, then I will say hello to you as well. So if this hello go and the second one router, again it said the hello back to you. So it will send the information, their AS number, their like K values, right? Just giving that information. And let's suppose the authentications and what else? The timers and the subnet mask. These all parameters, the same should be matched at this location also. If they are going to both match, then what happened? They send the second packet. They send the second packet that is known as the update packet. If this parameter is not going to match, they will not going to form any relations and your update packet is never going to be exchanged. So what is the update packet? Update packet is means, let's suppose we agree for the neighborship. When we send any kind of the neighbor between two routers, so update is going to be whatever the routing information I have, my neighbor is going to share to the another router, which is going to my routing update, which is going to be exchange between the router. So update is going to be every information which I have, I will just send to you. So even you can go and learn about the update packet. I will show you later, but for time being, update means I want to make sure whatever the route I have, I will just update to my neighbor. That's the update packets. Now they have the third packet also. In the third packet, they known as the query packet. What is a query packet? So query packet is basically, it is going to be, let's suppose I want any additional route informations. Means you want some information about any additional subnet, any route. So you just send to your query message to neighbor, hey, I was earlier knowing this particular subnet, but somehow I'm unable to find this subnet. Do you have that informations? Can you share me? If your neighbor have that information, it will reply with the reply packet. That is the fourth packet. And then final, it is going to be acknowledge packet. Yes, I received the packet. So if I go and learn this all, probably it is going to be in my book also. Let me show you. Here you'll see that. See. So a little bit different. They have written here, hello. Hello is just going to discover your neighbor. Request means update, right? Request update is like little bit confused here. Like specific information I want, that is going to replace with the query packet, and update is going to be provide all information. Query, if I want to get additional information, reply is just response or acknowledge everything. But if I go on the internet and I just search here EIGRP packet types, so you don't have to confuse what sequence I just explained, you have to follow. See here. So this is the packets, right? So sometimes books have their own language, right? But actual hello is going to be there, update is going to be there, query is going to be there, reply is going to be there, acknowledgement is going to be there. So see, hello, discover and establish adjacency, neighbor, routers. This typically send a multicast address. Whatever the multicast address we have, 244.224.0.0. What was the address? 10. Then update contain the routing information that's sent to the neighbor. Means whole routing information I'm going to send to my neighbor. That's update. Once we agree with the parameters. Query means any neighbors. Send the neighbor router when router need to find the alternate path or any other subnet informations as a successor. Might be you don't know what is successor, I will explain it. But that is going to be sent via the query message and reply when the query is going to come. If I have the information, I will reply that yes I have, and then finally it is going to be acknowledged. So this is how the whole process is going to happen when you build the EIGRP neighbor set. So you understand the basic fundamental of the EIGRP. What is a dual algorithm? In dual algorithm, still we have to do a deep dive because we have to understand these all parameters. This is a dual algorithm. Successor route, successor, feasible success. I'll explain again it in very deep. But for time being, let's understand how to build the EIGRP neighborship. Okay. So in the small lab, we'll try to do the same EIGRP neighborship. So you can understand how it is going to configure. Also, EIGRP can be configured in two mode. EIGRP can be configured in two mode. So EIGRP mode, one is a number and one is the named. So classic mode and the named mode. Classic mode, whatever the configuration I'm going to do right now, it's going to classic mode. And what is the name mode? Named mode is you just have to give the name based configuration of the EIGRP. So I will explain both of them more. So right now I'm going to do the configuration of the EIGRP, that is a classic mode, and then we'll go and discuss about the named mode EIGRP as well. So I will go here and remove the my both static route. So config T and I'll go here. If any question, please feel free to ask. I'm absolutely fine to answer.
All clear so far, sir.
It's
Thank you.
good. Santosh, if you have any questions, you can also ask, no problem. Okay, so now we remove the static routing configuration. Now we have to build the EIGRP, okay, and we have to make these two loopbacks to talk to each other. So now if I go and try to ping 2.2.2, it is not going to ping. So how I can make them reachable? What is the way of doing the configuration? So to make them reachable, I have to build my EIGRP configuration. How it is going to happen? Very first thing, if you go for the any EIGRP configuration, any routing protocol configuration, even BGP, EIGRP in Cisco, you have to type a syntax in config mode router, and after that you have to give the protocol name EIGRP and then AS number, OSPF, BGP, RIP. So I need to go, if I want to enable the EIGRP, the classic mode, I'm just saying that right now. Named mode we will cover later. Router, and you just put question mark. You can see all possible protocols. We have the BGP, EIGRP, IS, LIPS, mobile, ODR, OSPF, OSPF v3. So we'll understand what is OSPF v3 for IPv6. Even we'll do the IPv6 labs as well for the all routing protocols. So router, and what I want to configure, that's the enhanced gateway interior gateway routing protocol. Enhanced interior gateway routing protocol. So I will put as a EIGRP, and then if I put the question mark, it's having the number. This is for the classic mode, and this is the named mode. If I want to use the name based configuration, then it is going to be named mode configuration. So I want to enable just for the classic mode, right? So in classic mode, I will just put the any autonomous system from this range, because we already know what is the range. So let me use the range as a 1 2 as a AS number, or I can use 1200 as well, no problem. So this is the router EIGRP. Now it is going to ask, if you put a question mark, there is a lot of commands available in the EIGRP. Address family, auto summary, default, distance, like distribute list, EIGRP, maximum path, secondary, neighbor, network, lot of things we have. So what I have to do that, do I need to configure my network inside of the EIGRP? The answer is yes. I need to configure my network in the EIGRP. Then how it is going to configure? For that, you have to use this network command. Where it was there? Do you guys see network command? This enable routing on the IP address, right? IP network address. So this network you have to use. So I will go here and use the network. And what network I want to enable? I want to enable on this network. Let's suppose 172. So I will go here and put 172.16.10.0 and I have to give the wildcard. What is the wildcard? Just opposite of the subnet mask, and done. So my neighbor has been initiated. The moment I will done, hold on, let me show you what happening. Once let me debug, let me start a debug as well. So you guys can see that. I need to get out. Debug IP EIGRP. $1200, right? Neighbor. Okay. IP EIGRP. Notifications. Let me debug EIGRP. Packets. Okay. And events. So whatever the possibles. Okay, so leave it. Neighbors. So I enable multiple debug, right? Sorry for that. Now let me go and configure the EIGRP. So I'll go again here, router EIGRP 1200, and I will just put the network now. Network 172.16.10.0 and done. See. It is sending hello. Which interface? On the interface gig 0/0. It's trying to send hello. The moment I enable the EIGRP, it's sending hello to this interface gig 0/0 because we enable that network which configure on the gig 0/0. So this is the first packet. Hello is it's sending, right? But we are not getting any reply from anywhere. So if they are not getting any reply, then how I can make the neighborship? So let's go another side and configure the EIGRP and we'll see what is going to happen. So I'll use again router EIGRP 1200 here and I'll use the network 172.16.10.0 wildcards mask 0.0.255 and I'll click boom and we'll see what happening now. It's sending hello. It's keep trying hello. The moment I will configure this, it will also send the hello message, but I'm not enabling debug here. We'll see that one router it is going to be show everything. I'll done. Now I'm back to here. See how fast it is happening everything. Wait, let them do all the work. So neighborship is up. Now let me you all undebug all. Now see, I just stop the debug. Now let me show you. Till here it was keep sending the hello, hello, hello. Nobody was replying. But the moment I enable the EIGRP, another side it found new peer. You can see this new peer has been found, and then after they build the neighborship as a new adjacency. And they send the update packet. What the update packet means, whatever the routing table they have, they just send the all informations and then You see, they keep talking in different language, but they have the acknowledgement packet, they have the update packet. So the book was not showing the acknowledgement packet. This is the reason I want to show you in debug. It doesn't mean this book is 100% right? This is the book written by Cisco, but author doesn't acknowledge, put the acknowledgement packet. But here you can see this is the acknowledgement packet we are getting for the neighbor. So now you understand how the neighborship is going to build, because hello is going to say. Now if I going to say show IP EIGRP neighbor, you're going to find we have the one neighbor. Now I have the another neighbor also. I can enable that also, but I will not going to do right away. Now what is the requirement? We enable the EIGRP. That's done. After that, I want to make these two loopback should be reachable. So how they are going to reachable? I need to advertise this loopback also in the EIGRP table. So I will go here. If I ping again here 2.2, it is not going to ping, because it is not in routing table. Even I go in the R2, show IP route. This is not showing in the 1.1 route here. So we do not have anything in the routing table. So I cannot do anything. But if I'll go here, R1, if I'll go in the config T, and I'll go here and router EIGRP 1200, the classic mode, and put the network, that is a 1.1.1, and wildcard mask, this one. Boom. You will see that it will get the route here. See, I'm start getting the route with the D. D is equal to your EIGRP. You just focus here, D. And if I go here, see here, this is indicating the route you're receiving, that is your EIGRP route. And what is this? Sabir, what is this?
The AD value.
AD value. That's the 90. And what is this?
This is metric.
Yes. So in this route, we are getting this route having this AD value and this having this metric. And this is your composite metric. And this metric get calculated from the K1, K2, K3, K4 and K5. I'll explain what is this K1, K2, K3 and K4 later on. But keep this till here. But still, if I try to ping from here, this one, it is not going to ping. With the source 2.2.2. By default, without source is going to ping, but with the source it is not going to ping, because we have to advertise again my 2.2 route in my routing table. So I will go here. Config T, router EIGRP 1200, and network I'll go and give that 2.2.2. And now you'll see that this router also going to get show IP route. Clear? So we have the route. And now if I just try to ping from here to with source 1.1, it is going to be pingable. Any question till here? I will take 5-10 minutes more, just 5 minutes more, just to configure the backup link. Any questions till here, guys? Santosh, Sabir, Jason?
So will we get this handbook so we can read it, the theory?
Yeah, definitely.
next class?
You're going to get this handbook. Don't worry. Okay.
Thank you.
Yeah. All right. So if it is good, let me enable the another EIGRP on this network, and we'll see what is happening after enabling this. I'll enable on this EIGRP on the second network also. So I will go in the router EIGRP 1200 and network 192.168 10.0. Done. And I'll go here as well. Router EIGRP 1200 network. And you'll see another neighbor is going to build. Now it's done. And if you check show IP EIGRP neighbor, you have a two neighbors. You have a two neighbors here. And if I go here also, show IP route. Sorry, if I go show IP EIGRP neighbor, you are going to find the two neighbors also available here. So now we have the both neighbors available. Now see the magic in routing table. What is happening in the routing table? If I go and run this command, see here already I run this command, show IP route. You see it is having a two path, you can see, and both link having the same metric. Why? Because they connected with the same interface type, just one hop router, and the metric calculations which is happening based on the composite, not the link and everything. So I'll explain this calculation metric later on, but you can see they have the both AD but having the same matrix. So by default they are going to do the load balancing. Later we'll see what is the load balancing. The EIGRP support equal load balancing, and also it supports unequal load balancing. So in this case you see it's a equal or unequal load balancing. What is the case you're finding here? It's equal or unequal?
Equal.
Equal path cost.
Equal
Load
path
path
cost. So what is going to be happen? If I just try to ping from this to this link will send the packet, or this will send the packet, or both will send the packet.
Both. One packet will go from one link and the other will go from
One.
the
How we
second.
can verify? Let's do the debug. Okay.
Debug.
Debug.
So I'll go here, debug IP.
EIGRP.
Sorry, I need to enable. Okay, let's try to from different direction. Okay. Okay, so I'll ping from here to another link. So I will go here and ping 1.1.1 with source 2.2.2. So this debug is not showing. This debug is not showing. This is not going to show you the link information. Because debug is just capturing the packet from which source, from which destination this packet is coming. But if I want to capture the link label flow, then we have to apply the Wireshark, both link. Then it is going to show you. Debug is not going to show you the details. And other way, if I just trace 2.2.2 with source 1.1.1, you will see in the trace also sometime it's going to show the both path, which is going to clearly give the both link is going to be utilized. You will see that unreachable. Why? Okay, let me stop this debug first. Hold on. Let me trace now. Debug was there, na? So you are getting ICMP unreachable message from the neighbor. Let's do without debug. See, this will show your packet is going one from the one link, another from another. Debug is not going to show your details. It's showing that both path. Ideally, it's a one hop away, but it's showing total three hop because it's going to use one packet for the one link, another is another link, and that's why it's showing that all possible path. So in case of the equal load balancing, you are going to find the trace route is going to show all possible path, which is going to, I'll show you later on. We'll do this lab here again. When I do the equal unequal, I will show you how this first hop is going via this way, second hop is going via this way, and then they're going to make the end-to-end communications. So if I want to manipulate some metric, Let's suppose right now both having the same parameter. So definitely we'll do later on, but let me play one thing right now on the R2 side, and I'll go on the interface. By default, the interface bandwidth is going to be your how much? 1 Gbps. So I will go and load down the bandwidth of 0 by 1. You will see that gig 0 by 1, and I'll put the bandwidth 800. Sorry, 800 Mbps. Earlier it was, if you go in the interface gig 0 by 0, you're going to see this is the your bandwidth 1000 Mbps, right? But if I go 0 by 1, you're going to see now bandwidth is 800 Mbps only, not 1000. Now if I check show IP route, only we have the one path. It's remove the another path from the routing table. But if I just check the show IP EIGRP topology table, you are going to find both paths available for this destination. But you can see the metric are higher from this path 0 by 1. I changed now, and that's why it is not installing. If I do the unequal load balancing, then it is going to install, but I'll do later on, not today. But I'm just showing you. Even I just change the parameter of the metric. My route is removed from the routing table. If I go in this place now, show IP route, this is still using the both path because the link parameter is same when the route is receiving. Both link have the same equal cost. It's not end-to-end cost, local link cost. And if I change again this link cost, might be this side I'll change this one 0 by 1. So you can see this time interface gig 0 by 1. It's a 10,000, and I'll go 0 by 0 also 10,000. Now this time I'll change the 0 by 0 interface bandwidth. I'll go here and I'll put the bandwidth. It's going to be 900 Mbps. Done. And now check show IP route. It will remove your route from 0 by 0 and keep the local route based bandwidth calculations, which is the higher of this one. So lower metric. And if I go here, show IP EIGRP topology, you will see again we have the both route available, but this one have the higher metric 0 by 0. And this one have a lower, that's why it's a top and it's installing routing table. So that's all for today. I hope the session was good. You guys understand the basic routing, and also you guys understand about the some EIGRP fundamentals. Is it clear, guys?
Yes, sir.
Yes.
Thank you.
So meet you tomorrow again, same time, and be recharged, be energetic, okay? And we'll try to continue from here. Thank you so much. See you.
One
Bye.
suggestion,
Yes,
sir.
please.
Can we please make a WhatsApp group for our internal communication?
Yes, we can. Later we'll do that, okay? Tomorrow probably, okay?
Okay.
Okay.
Thank you.
Thank you, guys. Bye-bye.
Take
Thank
care.
you so
Bye.
much. Thank you.
Bye-bye.
Bye-bye.
Good night.